and in this video I'll be covering centre of mass or gravity. This is still topic 3.2 of OCR A level physics A specification. And so basically the centre of mass is a single point at which, or of which, all of the mass of an object appears to act. And basically what that means is, say you have a football of, my pens are up there now. So you have a football or some kind of ball like this. Well, the centre of mass is basically just the point at which all the mass of the whole football appears to be. So for a football, it would just be in the centre. And this point is where all of the weight acts. So this is where, when you draw free body diagrams, weight is drawn from the centre of mass. That's where all the weight acts. That's why it's also sometimes called centre of gravity. It's the same thing, it's just where all of the weight appears to act, or the mass, depending on what way you want to say it. And it always moves around this point. It always balances around this point of the centre of mass. There's two ways of locating this. So the first way of locating it is just by symmetry. Just write COM for short, centre of mass. So that is with symmetry. And this is only for use of regular shapes. So for instance, a circular shape, or a square. So you could say you had an object shaped like a square. Well, you can find the centre of mass of this object by just using symmetry lines. So using lines of symmetry to find where all the lines of symmetry intersect, and that is where the centre of mass is. So usually it's there, but this only works for regular shapes such as squares and circles, and that's where the lines of symmetry cross. The second method, we'll do it over here, would be by experiment. And to do this, it's for irregular shapes. So anything that's not regular, anything that can't really be drawn symmetry lines with symmetry lines. So say a weird shape like this. That's really weird. But what you'd do, number one, is you would hang the object freely, suspended from a ceiling or something like that, with a bit of string attached to it, and just let it come to rest. So say you've got there at any point, you've got it hanging from a piece of string on any part of the outside. So it could be here, anywhere that you want. And to find the object centre of mass, you need to use a plumb bob to draw, which is just basically, it's just a piece of string attached to a weight so that it always hangs vertically downwards. So you need to use a plumb bob to draw a line vertically downwards on the object. So as I've drawn here, it's being hanging from this point, and we're drawing a vertical line downwards to find its centre of mass. Now, once you've done this, you just repeat the steps and hang it from a different point, so here or here, and just repeat and draw a, I'll draw it again, so it's going to look different, but say then you're hanging it from this point here, then you use another one, and basically all it is it's where it crosses, like the symmetry, lines of symmetry for regular shape, it's just where the lines cross. But I'll write this out, so bear with me. And to make this more reliable, to get a more accurate value of where the centre of mass is acting, you could repeat it as many times as you want to get more lines and to more accurately find where the centre of the mass of that object is. So stability is actually determined by the centre of mass. And the base of the object. So say you have a wide base and a low centre of mass, base of wide object. So you have a wide centre of mass, something that looks a bit like this. I didn't take art, so like that. I can't believe I just couldn't even draw that. Wide base and very low centre of mass. So a low centre of mass, wide base, and that will give you high stability, so it won't topple over easily. What's wrong with me today? I can't spell. However, if you have a really high object, something like this, like a bookshelf or something like that, and that has a really high centre of mass, which is about here, which acts downwards, so here's centre of mass, and quite a small base, so it's not as wide as that, that's quite unstable. And the reason for this is, I'm running out of space, I'll do it here. The reason for this is things tend to topple when the centre of mass is outside of the base of the object. So for instance, for this tall, unstable object, and it was toppling, say, this way, like that, the centre of mass here, if you draw a vertical line downwards, is not within the base of the object. And that means it's just going to topple over. Something that is wide and is toppling slightly, but the centre of mass is here, the centre of mass is still acting within the base of its object, therefore it's not actually going to topple over, it's just going to go back to where it came from, down from this way. So that is literally just due to moments, which we will cover in the next few videos. I think it's the last one of topic 3, but otherwise that is pretty much it for this video. It's just remembering the definition and the two ways of getting it, and the stability of objects, that centre of mass, if it falls outside the object and it's tilting, the object will topple over, it will fall over if it's outside the base. That is literally just it. It's quite simple, but just a bit to remember.